So Justin, our Milltronics tech, is getting the machines nice and level. He's been over here getting these set up. So he's starting with the ML16. He's got this cool digital level there that he's been using to get it leveled in. So we're going to go ahead and jog it. We'll just move it 5 inches. Let that level settle out, and you can see the division there. So we'll go ahead and move it another 5 inches. But he's still working on it and letting it kind of settle in. I thought this would be a great video to show getting the ML16 leveled in. All right, so Derrick's been getting the TRM nice and level. I think he's got it about where he wants it there. So he's got a little program so it'll kind of run to the different areas of the travel. Let's go ahead and see the level. So it'll move to like the 4 corners of the travel and pause for 5 seconds. Well, it's spot on in the back there. I think it turned off. I don't see any lights on it. Did it just time out? Oh, okay. Pretty good right there. Level. That nice and level back there too. It's looking good. All right, so Derrick's been here getting the Milltronics machine set up. He's over here working on getting the Renishaw probe system set up now. I'll show you that. We've got the receiver right there, and he's getting that wired in. We have the tool setter here to set up, and then this is going to be the probe system here. So working on that. I just put a hole in that panel for him for the wiring. I'm going to go ahead and give him a hand, and we're going to set our new fixture plate onto the table here. So this is the Saunders Machine Works fixture plate that they machined for me. Got their cool logo right there engraved in it. So I'm going to go ahead and get this guy cleaned off, and Saunders provided the T-nuts and the bolts there that we need to mount this guy down. So, and what we had done, we actually had Milltronics send the specs on the table for the T-slot sizes and dimensions, and then they designed the plate to fit this machine. So we've got the rust inhibitors on there. We're going to get it cleaned off, and we'll get this guy picked up and see if we can get it mounted on the TRM 3016. All right, so we've got the new Saunders Machine Works fixture plate now mounted onto the Milltronics there. It looks great. The only issue that we've run into is the bolts really need to be just a little bit longer. So I'm placing an order to get some longer bolts, and I'm going to swap those out so that we have more thread engagement into the T-nuts. Alternatively, you could get some T-nuts that are actually taller to gauge the threads, but McMaster has these bolts there. The I forget what they're called. Low profile socket head bolts, I believe is what they're called. So get those ordered. And I wanted to point out that we also have, I bought 2 of the mod vices from Saunders when I was there. So we have 2 of these that we can use on the fixture. We've also got, these are all the rubber caps, all the little rubber caps that are gonna go into the holes to block those off, all the holes that's not being used. And you can just pop these out with a pick whenever you need to access the holes. We also have 3 sets of soft jaws right there. And then we've also got these jaw inserts that they make as well. You got one side is smooth and the other one has like a serration machined into it to add some grip for your heavy machining there, and then swap it around for the smooth side for your finishing. So we do have the 2 mod vices that we can use to get us started with on the Saunders fixture plate once we get this thing up and running. So Derrick is continuing. He's back there working on the electronics, getting everything hooked up and ready to go. And still a lot more to do. We got the air hooked up today. We haven't even seen the spindle run yet, so he's just doing his things, getting everything hooked up, and he's going to continue to on both the TRM and the ML16. I believe the ML16 is almost ready to go, but he's planning on being here for 3 days. This is the 2nd day. So he still has 1 more day here to continue working and getting both of the machines up and running. And then what's going to happen is next week, another tech from Milltronics, Steve, he's going to be coming down and actually working with me one-on-one for some training on these machines and kind of getting me familiar with the control panels and actually how to use them. So that'll be coming up next week. Derrick's been getting the Renishaw probe set up. So right now he's currently getting the actual probe here indicated and getting it run perfectly true there. So I'm just kind of watching over his shoulder, and he's kind of talking me through some of this stuff that's got to be done. But we'll go into some more detailed training next week on all this stuff right there. So I thought I would show you. So it looks like he's got it so far within almost 2 thousandths, right about. Yeah, about 2 thousandths. There's some screws in here that you have to use to adjust the probe itself to get it to run true. So he'll keep working at this and get that thing running probably pretty well spot on. All right, with just a few more little adjustments there, he's got it running damn near dead nuts accurate right there. I see very little run. That's a 10th indicator that he's using there too. Touching on the ruby, so that thing is trued up. So this is what we'll be using to locate work pieces, Z offsets, finding the center or finding the edge of parts, or touching off on the top of your material, your work pieces, vices, fixtures, all that kind of stuff. All things that I got to continue to learn how to use and hopefully one day become efficient at using all these tools. But real excited to see this coming in the way it is. So we've been getting the Saunders Machine Works fixture plate squared up to the travel of the table there. Got a 10th indicator on there, and I think we got it where it needs to be. So no, there we go. It's got a few little bumps, little high spots or low spots in there, but it looks like from end to end we're within maybe about a 1/10, which I think is going to be pretty darn close for having that squared up. I think that's going to work real good right where it's at, man. All right, so Derrick's been working on the calibration for the Renishaw probe, and he's gonna run this again so that we can capture a little video of it. He's been kind of talking me through it, but he's already got the he's already got it calibrated, but we wanted to run through this again so I could see the process. Go ahead, man.
So I wrote a program that's running a program in the background for probe calibration. So we're going to go and run the program. From run menu, we'll see probe cal is our active program. At that point, turn feed rates down just for safety. Hit start. Cycle start. This program's going to step you through it. So right now it's asking to hand wheel to the center of our bore. I'm going to hand wheel Z down. Just far enough so that Ruby is in the bore. We're going to hit enter. It's now asking for the diameter of that ring gauge that we're testing it with. That diameter is 2.076. Enter.
Yep, and that was a setting ring that I've had that I brought down for him to use.
At this point, the head goes up. It wants us to rotate the tool 180 so that it can look for any run out. The tool rotated, we're going to hit enter or cycle start.
That's going to go through the same process again.
Yep.
Okay.
It's going to touch another 4 points in that bore.
All right. There's the receiver back there. That is on a mag base, so that this can be moved if needed.
The head has gone back up. It wants us to return it back to its original position. Now we'll hit cycle start.
So is this the one where it's going to pick up, you said 16 positions now?
Yep.
Okay. And what is that going to tell us? What is it doing that for?
At that point, it's actually looking at the Ruby for any defects. So it's going to touch every side of it and right back into our calibration.
Okay. And it's going to map it out here on the screen as it's doing its thing, right? Yep. So it goes X, Y 2 times, huh?
Mm-hmm.
Okay. So it's touched all positions?
Touched all positions. It's just giving us a warning to make sure that you ensure the probe's back in the correct position. At this point, it's wrote into parameters, control. That's where all of our Renishaw info is. Scroll down a little bit, we have probe parameters, so it's wrote into all these X and Y offsets. 10th offset in X, 10th in Y.
The probe is a 10th out?
Yeah.
Okay.
Yeah, so that would be based on when we trammed it earlier. That is skewing the results for the tram if it's off at all.
Okay, and I think we had determined that it was about a 10th out.
Yep.
Okay. All right, so it found the center, and then Derrick has pulled it up here so that we can see what the probe actually measured, the bore being, correct?
Yep.
2.0476. And is that what we had, that's what we wrote down. That is actually what's on the gauge ring there, the setting ring. Yeah, 2.0476. It's actually engraved on there, so it's not only has it found the center, it's told us that the bore is what the setting ring is actually says that it's measured to, right?
Yep.
That's pretty cool. All right, so Derrick has the TRM 3016. It is ready to go. Everything's calibrated. The tool setter is set up. It is calibrated now. And the only thing left to do really is to start installing some tools in there. A vise up here where we could start doing some machine work. Also we still need to do the coolant, but I was trying to hold off because I have some coolant coming from Master Fluids and it hasn't arrived yet. And I really wanted to put that coolant in both of the coolant sumps. You know, I didn't want to put some other coolant in here and then the Master Fluid coolant show up and then have to pump this back out. So we're just holding off on that. But other than that, the machine is ready to go. It's really looking good. He just showed me the little, we just went through the little cycle of setting this tool right here. It's a 1/2 inch carbide in mill. That's the only tool that we actually have in there right now. He also installed my logo up here as well. And he is over on the lathe. He's still working on it right now. I think he's getting ready to, he's gonna make a test cut on this piece of 1045 old hydraulic rod and do some measuring on that to see if he's getting any taper in his turn. But I think he's about got this guy ready to go as well. Pretty excited. Pretty exciting times there. The Renshaw is all set up, ready to go as well. Hey, one of the features that he informed me about I wasn't aware of, and I just thought of it because I hear it. You might be able to hear the air. And so I asked him, he said this is a really common question too when you get you know, customers with new machines. Sounds like there's an air leak, right? But in fact, what it is that he says the machine's built so that there's 15 psi of air that blows through the spindle, right? And a couple reasons why. It's supposed to prevent coolant from working its way up into the spindle while it's being operated. And then the other reason is that it helps cool the spindle too, right? So after the spindle shuts off, it'll run for 15 minutes and then it'll shut off. That helps cool the spindle down, and then any kind of fluids that might have been working up in there, it's pushing it down. So pretty nice feature on the Milltronics. some of our first cuts in an ML16.